Hi, I'm Mike Burr, Android Enterprise Security Specialist. Thanks for taking the time to join us for Android on Air, our ongoing video series dedicated to helping organizations learn about Android and how to put the platform to work. Today, I'm going to talk about the best practices for deploying Android devices securely.
We're not going to typically cover here things like password protection. We're going to get a little deeper into areas that are commonly missed or areas where we found that customers may not quite understand or know that these capabilities are available to them. Before we actually get started, I want to kind of bring two things to you quickly. At the bottom of your screen, you have an area where you can ask questions and type your questions in live while we are presenting. And also, the answers, we'll have a team there that's trying to answer those. If you don't see your answer, typed in live by one of the team members here, please come back in a day or so, and you'll see your answers answered at that point in time. Or you can also review this recording or on demand. And then on the right-hand side, towards the very end of the presentation, there'll be a quick survey. Please take a few moments. It's important to us to ensure we've provided you with the great content. And then also it gives you the opportunity to ask us to do something in the future that may be important to you. Now, let's go ahead and jump in. When we talk about Android enterprise security best practices, we want to look at 5 main areas, and that is devices and partners, how you enroll the devices, how you build and deploy your applications, the management of the device to include applications, policies, as well as identities, and then finally services. These are the services that are available to you that layer on top of the devices that are free to you from Google that will actually help you deploy and manage those devices securely. So let's kind of jump in and unpack these 5 main areas. Now, when you're selecting a partner or an EMM or even devices, you want to make sure that you select devices that have Google Mobile services. And the main reason is Google Mobile services is what provides the newer modern Android management capabilities. Remember, device administrator is gone in Android 10. So you have to start using the modern Android capabilities underneath Android Enterprise. Now, the way we've standardized management capabilities across the ecosystem is with something called the CDD, or the Compatibility Definition Document. This is a set of rules and requirements that all OEMs and carriers must build their devices to pass the CTS, which is the Compatibility Test Suite. So again, an OEM and a carrier must use this CDD to build their specific versions of Android such that it will pass the CTS test. This is done for 2 reasons. One, to verify that the devices from the OEMs and carriers have a standard where all applications can run across all devices. The second is to mandate security and other components. The big one for this talk is security. There are many security components mandated in that CDD and are verified by Google with the CTS testing. And then third, in order to get a GMS license, all OEMs and carriers must go through other tests, one being a GMS test to get a Google Mobile Services license. When an OEM and a carrier gets that, we as Google deliver to them some root signing attestation keys that are embedded in hardware. And by the way, hardware has been mandatory since Android 8. So devices that come out of the box with Android 8 are actually mandated to have hardware-backed security, things such as a key store that keys are stored in. The other component here is that encryption, or one of the things that I still hear about, is encryption is always or not known if it's on, or I don't know what kind it uses. Well, here's something that's important to remember. Since Android 6 or Marshmallow, devices have been mandatorily required by CDD and verified by CTS to always have encryption on. You can't turn it off as a user, not even in developer mode. Encryption is hard-coded into the standards now, and it is always on. And by the way, that standard is 5 years old because Marshmallow was released in October of 2015. So encryption, again, is always on and cannot be disabled. Also, we use Google Play Protect to enforce verified apps, right? This is where we provide a service free from Google that helps detect malware or potentially harmful apps on Android devices. Android Enterprise also help standardize these management capabilities across all these devices, where we actually replace those vulnerable, outdated device administrator APIs I mentioned earlier with a standardized way to manage the devices. Now listen to this if you don't hear anything else. Android Enterprise standardized the management across all OEMs and devices that are Android 6.0 and above and have Google mobile services. It's a standard set of APIs and capabilities built into all Android devices today. And then finally, one of the things we've also done over the past several years is created something, an Android Enterprise Identity, or a managed Google Play account, which removes the requirement for you as enterprise customers to use consumer Gmail accounts. Don't do that. Best practice is do not ever use a Gmail account to manage a business device. Use managed Google Play accounts unless you are a Google customer, which in fact, then you could use a full Google domain account. So let's move a little bit further. Now that we have a standard way to manage those devices, right? Android is a diverse ecosystem. Many OEMs, again, Android Enterprise Security, standard across all of these devices. This is a small subset. And then those features that can be controlled in security have also been mandated in the management and security ecosystem. And that's done with something called the Android Enterprise Recommended Program. It really uses standards that simplify the choice for businesses so they can confidently select, deploy, and manage Android devices and select partners that meet elevated requirements that enterprises require. So you can select your devices confidently, you can deploy your devices confidently. And as we can see here, devices that are on the Android Enterprise Recommended list, these are devices that are tested and validated by a team here at Google. And a few of the requirements are these devices must have Android 8 or above. They must get updates, security updates, that is, within 90 days from release of the time Google releases them. They also have minimum hardware specifications, and they must support the current shipping release plus one-letter upgrades. So that gives you a support runway of 2 to 3 years. You can find out more information at androidenterprisepartners.withgoogle.com and look in the solutions directory to find your devices and partners that are Android Enterprise recommended. Now, as we move on, we kind of moved from devices and partners. We know how to select partners that are trusted and validated, and we understand that this new modern Android Enterprise management capability is standard on all devices. But how do we deploy those devices securely? One of the best ways is to use something called zero-touch enrollment. This provides administrators a fast, easy, and secure method of deploying corporate devices. The best thing here is that it's enforced, which means you can drop ship a device directly from the purchasing agent, which would be the carrier or wherever you purchase your devices from, directly to the users. When the users unwrap the device and they turn it on for the first time, it just begins an enrollment process. Essentially, there's no way to break out of that enrollment process. And if you do, as a user, try to break out of that, the device will reset itself and then again go right back through this zero-touch enrollment. So use zero-touch enrollment when possible. This makes it easy for you to deploy, and it also enforces an enrollment so that there's no opportunity for a user to actually do something wrong, which could compromise the device. Okay, so now we're going to talk about private application best practices. As a enterprise customer, you often will build private applications for deploying in your enterprise only and not being on public Google Play. So here are 7 of the points that I think are beneficial for you to use when you build your private applications. First, use certificate pinning. This is a technology or a technique by which you can require your application to use specific certificates and only trust certain certificate authorities. This is a technique that prevents man-in-the-middle attacks. So use it when and if you can. Second, use the Jetpack libraries. The Jetpack libraries was built by Google. It has a trusted and validated set of security libraries that help you build into your apps so that secure communications between your app and your data center are being used. Third, do not hard code tokens or connection strings into your apps. Use your managed configuration technology. So when you build a private app, build the capabilities to deliver hard coded or sorry tokens or connection strings or even proprietary information to the application after it is installed through managed Google Play. It's a misnomer to think that your applications are safe on a device because APKs can easily be extracted or scraped off an Android device and reverse engineered, even if you obfuscate your code. Um, so it's better to not hard code that information and use the managed configurations instead. Fourth, implement TLS 1.3 when possible. It is the latest and greatest standard. It is implemented in Android 10. It can downgrade if required. However, we recommend using TLS 1.3 because one, it is up to 40% faster. Two, it removes support for certificates that were signed with older or vulnerable SHA-1 hashes. And three, it actually encrypts and secures more of the handshake, so it prevents man-in-the-middle attacks. Five, use the Android key store. Do not write your own capability to think that you're storing your keys securely. Use the Android key store because remember, devices 8 and above are using hardware-backed key stores, which are much more and exponentially harder to extract keys from. Six, try not to use random SDKs. If you must, use ones that you know or that you trust from reputable sources. We often find that developers use SDKs to get a job done. However, many SDKs that they find out on the internet or from even vendors have vulnerabilities. And then lastly, do not share your private app signing keys with third-party vendors. If you have a third party building your applications for you, you can now, through the managed Google Play Store console, you can provide what's called upload keys to your vendors. This gives them the capability to sign the APK they built for you with the upload key, and it gets installed or inserted into your managed Google Play console. Then you have the capability to sign that with your private key and then deploy the app. So this actually protects your private keys from being exposed. Also, use app signing version 2 and 3 if you can, because it protects the entire APK and allows for ratcheting, which is where if you do require an APK signing cert to be ratcheted forward, you can do that with the APK version 3 now. Now, when we get to the application store, we want you to use managed Google Play. One of the biggest things we see, and in the previous slide, is when you build private apps and you don't use managed Google Play, then the Google Play store doesn't have the capabilities to scan your apps. So as you can see here, a couple of use cases or why you should use managed Google Play is number one, it will scan your app vigorously for malware, poor coding practices, and vulnerable SDKs, just like we mentioned previously. So please deploy your private apps through managed Google Play because it makes them stronger. Now, when we find those poor coding practices or improper use of certificates or vulnerable SDKs, it's a great opportunity for your developers to learn best practice when it comes to building secure applications. We work directly with that developer if things are found and help them build their apps much stronger to have best security practices. Third, you have access to developer advocates. So if there's questions on how to use Jetpack, for example, you now have access to developer advocates that can help you answer questions about how to build these applications. The managed Google Play is also ISO 27001 certified. This means that Google has put in place standards that meet this requirement or this certification to ensure that your applications and your data is handled properly. And then lastly, it protects your app signing keys, as I mentioned earlier, because you use what's called an upload signing key versus using private keys for your third party vendors. It helps those things that I mentioned earlier, such as the vulnerable SDKs, improper AP key signing. It also allows you to have analytics on your apps, and it helps prevent data loss from building insecure apps. Now, the other part of this process in the cloud is that we build a stronger security model in Google Play with ecosystem partners. At the end of last year, 2019, the App Defense Alliance was created or initiated by Google, where we now partner with three external vendors, ESET, Lookout, and Imperium, and they actually help us quickly find apps on Google Play, which we call potentially harmful apps. And we can actually take the appropriate action and remove those potentially harmful apps from devices as well as the Play Store um, in a much faster way by using the technologies from these three external partners. So all apps that are now uploaded into Google Play, whether it's public Google Play or managed Google Play, has stronger scanning capabilities to help find potentially harmful apps in and around your enterprise use cases. You also want to enforce Google Play Protect. There's capabilities in your EMMs called strict verify apps. This basically disables the ability for your user to turn it off. Now, there's five main things that Google Play Protect does for you. It, number one, provides an automatic, always on, built in play protection capability where it detects potentially harmful apps. It's built onto all 2.5 plus billion devices. It's also updated all the time, and it uses the latest protections from Google to include Google's AI. So it helps detect even those random 0 days that are doing something crazy by looking at signals of those apps. Fourth, it scans apps from within Google Play and all apps that are installed on the device from external sources, whether it's a third party app store or an application is sideloaded. In fact, it even scans apps in the system partition during an update from a carrier. For example, if the keyboard app gets updated, Google Play Protect actually scans that keyboard app in the system partition as well. And then finally, it remediates bad apps or potentially harmful apps by removing those apps and providing signals to the EMM so they get the status of what Play Protect sees the device as. Um, Now, when we talk about device compromise, Google has implemented something called SafetyNet attestation. So we highly recommend that that you enable this feature in your EMM. Most EMMs today have enabled and built in the SafetyNet attestation components from Google. The SafetyNet attestation does something really well, and it checks the integrity of a device to ensure that it has not been compromised. Now, if you remember back in the CDD and CTS testing, when a device gets a GMS licensing or just GMS license, when it passes GMS licensing, we deliver something called a Google attestation root signing key that is stored in hardware. Now, when a device is prompted from an EMM to do a SafetyNet attestation check, Google Play Protect and Google Play Services gathers up some signals about the device and signs it with that attestation key. It then sends it over to the Google SafetyNet attestation service and looks at that attestation call to determine, based on those signals, if that device indeed has been compromised in some way. It then returns a signal to the device with in assigned capability or in assigned fashion, and then the EMM can pick up the results, whether it was a pass or fail. Now, combining that with compliance, the EMM can actually take action to either wipe or to block access to corporate resources. So use SafetyNet attestation. It's free service from Google, and it will help protect your fleet of Android devices from compromise. The security updates, you want to require security updates, whether it's 60 days or 90 days or whatever your risk management team has mandated. The EMMs can actually pull via an API the security update date. Security updates are delivered on dates, they're not versions, because it makes it easy for you to see as well as anyone else to understand the actual date of the update. So the EMM can pull that security update, and based on compliance, they can then restrict access to corporate resources and or even wipe the device or the work profile on a BYOD device if the security update is not within compliance. So use that compliance check to ensure your devices are getting those regular updates. A couple of policy best practices, again, not passwords or screen capture, but some things that are commonly overlooked. Use work challenge on devices that have a work profile and a personal profile. A work challenge does two things. One is it can require a separate, stronger passcode or password to get into the work applications. And more importantly, it creates a secondary or another encryption key and encrypts the work data differently than the personal side. This gives you a stronger separation of data when you use work challenge. Also, encrypt or prevent device backups. In other words, if you are going to allow users to back up their devices, there is an API that requires that backup be encrypted, and that encryption must be de-encrypted with a key that is on the device itself, so it can never be unencrypted off the device. Also, turn off developer options, OEM unlock, and USB debugging. I think this is standard for most folks, but I still find a lot of people are not aware that these capabilities exist. This actually prevents an attacker that may have found a device or stole a device from actually connecting it to a third-party tool to actually extract data, as well as the ability for users to install applications over a USB connection. Now, to wrap it up, again, we covered the main areas today where we discussed the main best practices for securing your devices, and that covered the device selection and the partners, how to deploy apps and use a couple of best practices, as well as those new management policies. Again, use Android Enterprise recommended devices as well as partners. Deploy with zero touch when possible. Use the tools and services available to you from Google. And finally, use Managed Google Play to help detect against those threats. Thanks again for joining me today. You can find more information at android.com/security or android.com/enterprise. And please tune in to androidonair.withgoogle.com to listen to all the previous recordings and check for new ones. Thanks. Have a great day.